Hi, yes, thank you very much. So my name's Chris Beeley. I work at Nottinghamshire Healthcare NHS Trust. Shiny is the thing that I'm probably known best for. I do other things, but nobody ever wants me to talk about them, sadly. So I'm going to talk to you about Shiny today. I've got quite a lot to get through, so I'm just going to sort of power through it. What I'm trying to do is give a mix of things, because I know people are at different stages with R and people at different stages with Shiny as well. So I'm gonna start with the basics, and then I'm going to try and show some stuff throughout that's maybe for more people who've used it a little bit. Then I'm going to try and finish with some stuff that maybe people who have been using Shiny for a while might be interested in. So depending on who you are and what you're interested in and what you've done before, you might get lost at different points or whatever. Don't worry about that. That's sort of intentional. And obviously it's all in the GitHub, and you can look at the slides, and as Alicia mentioned, it's all it'll be on YouTube anyway, so you can always catch up with it later. Right, so Shiny. So what is Shiny? So Shiny basically is an R package, as you probably gathered. It's a programming framework basically for building web applications. And so what that means essentially is it's a lot of HTML, JavaScript, and CSS, which are all called from R. That's quite a useful thing to understand as you get better with Shiny, because one of the things that I really like about Shiny is that you can write Shiny applications with no knowledge of any of those things, no HTML, JavaScript, nothing, just in pure R code. But actually Shiny is very accommodating, and if you want to add bits and bobs of HTML and JavaScript and CSS as you go through, you can. So sorry, I was just looking at my Slack. It was Tom, and he's just talking about the webinar I'm on. That was a rookie mistake. Yeah, so anyway, so as you learn more and more, you can actually add little bits in. So I know some people who are really good at JavaScript, for example, they will tend to use Shiny just for the kind of workhorse, just for the real data stuff in the background, and all the interactivity stuff they will actually just layer on with JavaScript. So it's a very flexible approach like that. So that's what it is. That's what Shiny is. So what does Shiny do? So Shiny does this. This is the most basic Shiny application. This is one of the applications that comes bundled with the package. You can actually interact with this, but I tend to find if I interact with it, it makes the slide go a bit weird and I'll have to reset, so I'm not going to bother. But it is an interactive application. So that's the sort of the Hello Shiny, if you like. That's the most basic one. People build all sorts of things with Shiny. So people build lots of, this is like a sort of statistics teaching tool that's got all sorts of weird and wonderful things to do with distributions and stuff on it. People build things with nice maps. So that map that you can see over on the right, that's a leaflet map. That's another R package, which wraps a JavaScript library. If any of you are familiar with that package, that's where that's from. All those maps are interactive, and you can zoom in and pan and all that kind of thing. And there's absolutely loads and loads of stuff. If you just Google around, if you go onto the RStudio Shiny website, there's loads of applications on there. They do all sorts of different things. If I had more time, I would show you, but there isn't a lot of time. But I encourage you to go and have a look and just see the range of different things that's possible with Shiny. Right, so that's what Shiny is. So let's talk about how Shiny works. So the key thing to understand about the way that Shiny works is that Shiny uses what's called a reactive programming paradigm. And what that means is when the inputs to something change, it changes itself. So say the graph is dependent on, say, a date. So you might have a date range. So you're selecting a particular period of time for a ward, say. If a graph depends on that date range, every time you change the date range, the output will change. In technical, in the Shiny world, what we call that is they take a dependency on inputs. And so what's so powerful about that is it's done automatically. You don't have to write any code. You don't have to think about it. All you do is you just write your code. You write the graph. You include some sort of reference to the date range within that code, and that graph will then automatically update when the inputs update. For those of you who don't have a particular programming background, that possibly doesn't sound that revolutionary, really. But the thing that, if you've done programming in other languages, say like JavaScript or Java or something like that, you'll understand that in a normal programming framework, none of that takes place. So you have to do that all of yourself. So if you're writing, say, a Java application that you want to be interactive, you have to write all of that code. So everything that depends on something else, you have to set up all these little bits of code all over, taking all messages all over the place. So Shiny does that all for you. does make things a little more difficult in places. So writing CRUD applications, a CRUD application being like a simple database application, can be quite hard because you have to control the exact state of the application in a quite careful way. And although Shiny does a lot of this stuff automatically for you, there are actually ways of controlling the reactivity. I'll touch on that briefly later. I don't have a lot of time to go into that. But the most important thing to know is that most of it's done for you automatically, and sometimes that being done automatically can create problems, and there are ways and means of controlling that where that's necessary. So that's how Shiny works. So let's now talk about how to build a Shiny application, how to write your own. And there's a sort of key concept here, which is important to understand before we proceed. Basically, there are two bits to a Shiny application, and when you see people talking about Shiny applications and writing them, you'll see them talk about these things. There's what we call the UI bit, the user interface bit, and that tells Shiny what inputs there are, whether there are, like, say, a date range input or a numerical input or a text input, anything that you want to put into the application. And there's all the outputs. So there's a graph and there's a table and there's all that kind of thing. And the UI says what the inputs are and where they are and what the outputs are and where the outputs are. That's all done in the UI side. Then on the other side, which we call the server side, that's the bit that tells Shiny how to actually make it. So Shiny will go to the UI and there'll be a graph and it will say there's a graph here. And so what Shiny will do and then say, well, how do I draw that graph? And the way that it knows how to draw it, it will go to the server side and look in that code and read it and say, oh, that's how you make that graph, and it will appear. So that's the fundamental difference that you need to understand, basically. So once you understand that, you can then understand how to actually write the exact code. And I'm going to talk now a little bit about how precisely you sort of structure the code. So basically, Shiny includes a lot of functions that generate inputs, like date inputs and numeric inputs, that kind of stuff. So you give a load of inputs on the UI side, and every input that you define has a name. And then you lay out all your outputs, your graphs and tables and all that kind of stuff, and all the outputs have a name. So that's all a UI is, really. It's just a collection of widgets that take information in and take the information out with names. And that's the UI. UIs tend to be quite short in the main because there's not, there's not usually a huge amount of that to be done. The server bit tends to be longer. So on the server side, using the names you've just defined, you tell Shiny how to make each output. So it will go, as I say, to the graph, and it will say, how do I draw that graph? Read the server code. That's the name of that graph. That's where I find it. And that's how you draw it. And the server side code can also access the value of the inputs you defined using its input $name of input. So this makes even more sense if we browse the code, which we're going to do in a moment. So just hold that thought just for a second. I'm just going to very quickly, and to be honest, I hate talking about this because it's just more there's like multiple things to understand, which is unfortunate, but I have to tell you both because if you don't know both, you'll read code on the internet and not understand why it's different. So actually two ways of defining Shiny applications. There's one way you separate the server code and the UI file into two different files, and they have set names, one called server.r, one's called ui.far.r. And the other one is just a one file called app.r. Now, I absolutely loathe and detest single file applications, and I will always teach multiple files forever. Except, actually, that's not true, because actually changes are afoot. Our studio seem to be dropping support for multiple files in the wizards. That seems to be going. And Hadley's forthcoming book on Shiny, which you can read online, makes no reference to two-file applications. So changes are afoot, but I'm going to touch on that a bit later. I don't want to labor that point just now. So I'm going to come back to that later. But for now, we're going to stick with two files, and because that's what I've grown up doing. I've been writing them for about 7 years, and that's what I've always done. But I think actually maybe there are things coming to change. Right, so let's have a look at some code. So let's make an application. So we can just make it live just to show you the code and also just to show you how easy it is to make a Shiny application. So I'm very much hoping you can see my RStudio window. I'm sure someone will signal to me in the chat if you can't. So all we're going to do is we're going to go to the new file menu of RStudio, and we're going to go to Shiny Web App, and we're going to click, and a nice little wizard comes up. And let's just put ourselves in a different directory. Oh no, that one's fine actually. Let's just let's just make a new folder called temp to put it. That's fine. And we're going to select multiple file down here. As I say, you can select single file or multiple file. And let's just call it test. And that's it, create. Boom, and it will appear. I've obviously made my font size absurdly big for the purposes of the webinar. So I'm just going to get rid of some of the stuff at the top so we can see a bit more clearly what's going on. We don't actually need that thing at the top either, so I'm going to get rid of that. And I'm going to do the same on the server side as well. Right, so just very quickly, let's just return some of those points that I was just talking about. So this is the UI. This bit here right at the very top, this is just sort of boilerplate. You can just, as you write more applications, you'll start to understand what that does and how you can change it. But when you're beginning it, it's not important really. Just leave that as it is. This obviously is where the title of your application goes. So you can change that if you wish to something else. Application title. And this is a sort of business end. This is what I was talking about. So that very basic Shiny application we saw at the beginning that looks like this. This is what's called a sidebar layout, because there's a sidebar here with the inputs and a main output section there. That's what the default Shiny application looks like. You can see it here. So this sets up the sidebar layout, and then we put things in the sidebar panel. So the inputs will go in here and the outputs will go in here. You don't have to put the inputs in there and the output. You can put anything you like wherever you like, but users will tend to expect that. So that's usually better. And we can see very simply here, this is an input generating function. All we do is give it a name. So we call it bins. This is a user label. So this is what the user will actually see. And then you can see down here the output, and this is also given a name. So this is the fundamental thing in Shiny, is just creating widgets and giving them names. So you can see we've called the input bins and the output dist plot. Now if we go over to the other side, you can see very clearly this is where the output's defined. So when Shiny comes to the UI and says, how do I make this graph down here, it will just pop over to here and read this code in here. And you can see also, as I mentioned, the value of this input here can be accessed very simply using input $bins just here. So it's input $ for inputs and then output $ for outputs. And you just use the names that you defined in the UI. And that is basically how you write Shiny applications. So pretty simple at its most elementary, I would say. So let's just do a very quick bit of live coding just to tempt fate. So let's just add a title. This is I'm building a one-day Shiny course that will be offered through NHSR at the moment. This is the first thing that you will do on the one-day Shiny course. So we're just going to add a title. So all we need to do is just going to add another input in here. So let's call that a text input, and we're going to give it a name. Let's call it graph title. And then all we need to do is just go over to the server thing, and we need to pick up that title. This is a base R graph instruction. Some of you will never have seen that in your life, and you never will again. But take it from me that the way you give them a title is you say main equals, and you just write input $ and the name of the input that we just defined, which I'm pretty sure was graph title. Yes, it was. And now if we just rerun, hopefully I've done it right. No, I haven't, because I forgot the output. That worked beautifully well in the training as well. Yes, I forgot to give it a human readable label. Give your graph a title and rerun, and there it is. So you can just write in here, and as you can see, this is the reactive programming, sort of demonstrate. You can see every time this changes, the title changes. I didn't tell Shiny to do that. It just knows. It knows that this depends on this. So every time this changes, that changes. That's reactive programming right there. So that's it. So that's that's Shiny 101. So hopefully all the beginners are satisfied now. I'm going to press on now, and I'm going to show you some other bits and pieces and tricks that you might want to add as you get more and more into Shiny. And I'm sort of showing these in the order that you might conceivably want to do them. So I'll be showing the sort of more simple things and then perhaps building as we go through. So the first thing you might want to do is you might want to have more than one output on the screen, but not crush them all together. So when you want to do that, you need a tab set panel. So the code just looks like this, and this relates to an application which I've made for this very purpose, which is here. Again, all this code is in the webinar GitHub, so do go and have a look. And this looks like this. So you can bring some graphs up here. So this is a tab set panel over here. So you've got the graphs here, but then your user can say, well, I'm not interested in graphs, I want a map. And then they can have a map just here. And then obviously you can add, it's not just 2, you can have as many as you like. And the code for that is very simple. So you just call tab set panel, and then within that you call each instance of tab panel. They each need a name. That's something for your user to click on so they know what it is. And then you just write the output within there. You'll see I've given it an ID and a value. Now that is optional. It will run without either of those. But the reason why I've put those in is to show the kind of thing that you can do if you do leave them in, which is the next thing I'm going to show, which is something I'll call a conditional panel. This is something that you quite often want to do as well. So a conditional panel allows you to show and hide UI elements depending on what the state of the application is. So often it's good user interface design, basically, that if a control doesn't do anything on the screen that it's on, it shouldn't appear, or it should be grayed out, because otherwise people click on it and wonder why nothing's happening. So that's what this is for. So that's why you see in the previous slide, I gave the tab set an ID of tab set. You can see here, and this value is graph here. So you can see them illustrated here. So this is what the value of the tab set is it graph. So what all that's saying basically is, has the user selected a graph? Is the user looking at a graph? If they are, then show this control, and if they're not, then don't. Just very quickly, you might be looking at this thinking, why does that look weird? The reason why it looks weird is because it's actually quoted JavaScript, which probably sounds a bit more intimidating than it is. Depending on what you're doing, certainly if you're just testing for equality in JavaScript, you can just relax. All you need to do, you see, this would normally be a $sign in R, wouldn't it? And all it's just a dot. JavaScript doesn't do dollar signs, it does dots. So as long as you're doing something simple like this, you just write input dot tab set instead of input $sign and then equals graph. If you're doing other things like testing if something is a member of several things, to be honest, it gets more complicated. You'll have to learn a little tiny bit of JavaScript if you want to do that. Do Slack me if you're interested. I can certainly have a chat to you about that. Let's just show it working. Oh, it's reset itself. So as you can see here, this control here, it controls the graphs, but when we're over on the map, it doesn't do anything because all the trusts are shown on the map. So you can see it disappears. So that's good UI design, is that whenever a control is visible, it should do something. That's a basic of UI design. So that's something else you might want to do. Here's another something you might want to do quickly. So sometimes you might want to take a bit more control. Instead of using the sidebar panel setup that we've done, you can actually do the whole thing from scratch. And this is shown very simply here. All you need to do is select rows. So the rows obviously go on top of each other. So you have a row of something, and then another row underneath it, another row input, and each of those goes within the rows. And then you just define the column, the width of the column of each. And the thing to understand is just that these widths should add up to 12. So this fluid row, you can see, will produce 2 outputs of the same width because it's 6 and 6. Similarly, this one down here, there'll be lots of room on the left because that's width of 8, and not so much 4 on the right. There's other things you can do with that if you want to do like offsets and all that kind of thing, but that's the basic idea. So that's something you might want to do if you want to take a bit more control of how the application is actually laid out. Right, I'm just going to pause there briefly. Is there anything coming through on the questions or anything that I should talk about?
So let's have a quick flick through. We've had one question asking are the slides going to be available. We'll be posting this recording up on the web afterwards, but I'm sure that you'll be able to provide the slides and the rest of the content.
They're already available. I'm like a good person. I pushed them to GitHub before the weekend, so they're already. You can look at them now if you want to. Excellent.
So I will get that link in the chat very shortly. There was a question that came through. We need to apologise. We had originally planned to use Zoom for this session, but our organisation banned the use of Zoom about 2 weeks ago, so we had to quickly switch over. So apologies for that. In future, we'll probably be using this platform, and we will make sure to send out the correct links in the future. Let's have a quick flick through the rest of the questions then. Can you use a pipe operator, or do arguments functions need to be nested?
Oh, that's a good question. I suppose it depends what you're doing. I wonder which particular bit they're talking about. Certainly in the server side, you can use pipes as normal. I think some of the UI functions take pipes depending. So for example, I know the leaflet package uses pipes. It sort of depends on the package, really. I think it depends what you're doing. I wonder if I've got some leaflet code that I can just very quickly show. So the leaflet package supports piping out of the box. So yes, so there you go. So you can see I've used it for in the leaflet proxy function down here. I hope that sort of answers the question.
I think so. So another question's come through. Reading the tea leaves, are you suggesting we will probably have to rewrite all our multi-file programs into single file at some point?
Yes, I'm going to talk about that later. I really want to talk about that because
Cool.
I think it's quite an interesting area. And I mentioned it on Twitter, and everyone was like, "Oh, we didn't know anything about this." So I think it's a good thing to talk about.
So yeah, you also mentioned a Hadley Wickham Shiny book. I'll make sure that goes into the chat throughout. And there's a question about which dataset are you using? Are you using something from SQL or somewhere else? I think this is just a fixed dataset.
Yeah, the application I've built it using NHSR datasets application, so it's from the A&E dataset. As I say, if you have a poke through the code, as I say, it's already on GitHub, so you can have a poke through it live if you like.
Awesome.
Okay, cool. Right. So that's the UI bit. So that was a natural stopping point. So now I'm going to talk a bit more on the server side. And again, I'm going to go in sort of order of when you might want to actually do things. So this is the most important thing you're going to do, I would say, on the server side, other than the absolute basics. And so what this is you using what's called reactive expressions. So reactive expressions they're just like outputs. It's just like a graph. So a graph will change when its inputs changes. Well, a reactive expression does the same thing. So a reactive expression changes when its inputs change. But the important thing that's different is that you can serve multiple outputs with them. So essentially what they allow you to do is to maintain any code that fetches and cleans data in one place. So if you write a Shiny application naively, if you have, say, 4 graphs and they all depend on the same data structure and there's some sort of elementary filtering or something like that, you will have to write each of those in each of the 4 graphs. So you've got 4 sets of code that does exactly the same job that you're maintaining in 4 places. So that's obviously bad practice from a sort of programming point of view. But it's also bad practice if those things involve fetching data from an API, from an online API, or if they involve computationally intensive work or something like that. You don't want to keep rerunning it. So the important thing to understand about reactive expressions is that they cache their results, which means that they run once and then they won't rerun again every time a new output comes to check. So I've got a diagram to illustrate. So this is the sort of this is the naive version of Shiny. So you can see here there's the green inputs and there are some red outputs. So if the value of input 1 changes, then both output 1 and output 2 will rerun. So if they contain the same code or computationally intensive code or an API load or something, they will both run. And ditto, when input 2 changes, both of output 2 and output 3 will rerun as well. So they potentially taking up a lot of CPU cycles. So that's bad. You don't want that. What you'd rather do instead is rewrite it like this. So what you do is you have a reactive object that takes a dependency on the inputs. And so what that means is the reactive object will still change whenever the inputs change, but all 3 outputs can now access it with just 1 run. So output 1 will access the reactive object and it might rerun and say, yes, the inputs change. I'll get you a fresh set of the data. Here it is. But then when output 2 comes along, it's already there. So the reactive expression knows that the inputs have not changed. So the reactive expression will just say, yes, it's fine. Nothing's changed. Here's the old data. And then similarly, output 3 says, I want some data as well. The reactive expression says, yes, that's fine. None of the inputs have changed. So here's the data that you want. Yes, so it's hard to overemphasize how important that is, really. If you're building even a moderately complex Shiny application, you're going to definitely need to use them. So let's just have a quick look at the code. It's pretty simple, really. All you do is you just give it a name. So I tend to call it something to do with data usually. So this one is filter data to indicate that I'm filtering by date. and then it's just you just say reactive, and then put the data expression within curly brackets, and that's all you need to do. So you can see here, all it's doing is it's taking, this is the main data set out of the NHSR datasets package, and it's just filtering it by the date range, and that's all it's doing. So this reactive expression will now hold this value. The only other thing to understand is that a reactive expression is not an object, it's an expression, it's a function. And so it's something that returns a value. And so what that means in practice is it needs brackets after it. So you can see down here, this is the server side code. So you can see we're calling filter data, which is the name of the reactive expression, but you can see we've got brackets after it. And once you've done that, you can just use it normally. So you can subset using a $sign just as normal. You can just treat it as a normal data frame. So instead of being a data frame, it's an expression that returns a data frame. Just to add to that, you don't necessarily, I think people usually return data frames. You don't have to return the data frame. You could return a list, you could return a number, you could return anything you like. I think it's more usual to return a data frame, but whatever you like. So that's how this works. And this slide neatly moves on to the next thing that I want to tell you about, which is also something you might want to do quite early on, which is render UI. So the thing to understand about the way that Shiny applications work is that the UI side is done first once. So when the application loads, the UI is loaded and then that's it. It can't go back. And so what that means is that the UI is not inherently dynamic. So one of the early Shiny applications that I wrote, it was about data for a lot of different teams, but those teams would sort of go in and out of existence depending on when you were looking at. So they didn't exist all the time. And so what that meant was the UI need to understand what time range the user was looking at in order to know what type of team, which teams to show. And in order to do that, you need to use what's called render UI. It's pretty simple. So on the UI side, all you do is you just use this function here. So all this does is it tells Shiny, you just call UI output and again, give it a name. Everything in Shiny is just giving things names. So Shiny will just get to that and say, oh yes, that's a piece of dynamic UI. I know how to render that. I need to go over to the server, so that it will go over to the server code and then read here. And you can see here the name here is replicated here, just as it was with the graph. And it's very simple. You just call render UI and then you just write whatever the normal. There's no difference. Once you're inside here, this is just common garden UI code that you'd write anywhere else. The only difference being, of course, that it has something dynamic in it. So this here is dynamic. So this would not work on the UI side because the UI does not have access to the values that the server has, but it does work on the server side. So that's something that people want to do quite early on. I mean, what you can do, in theory, I could have just given them every single team that ever existed, and it would have worked, but it would be bad UI design. They'd have far too many teams, and they'd click some teams, and nothing would come back, and they'd be confused as to why. So if you want to have, a well-designed UI, that can be quite useful. Right. Okay. So moving on, something else you might want to do on the server side is check for errors. So sometimes Shiny applications throw errors, and it's not because there's anything wrong with the application. It's just because it's waiting for an input from the user, or sometimes it's just because it's recalculating something and that value is not available yet. And if you don't handle those errors nicely, what you get is you get angry red error messages on your output, and users will think, oh, this is broken, this isn't good, and just turn it off. So the validate function is a really useful way of making sure that you don't get confusing error messages. And this is included in the application that I wrote for this purpose. So you can see here, when this first loads, it says, please select a trust. And what it's saying is this graph is not broken. There's nothing wrong with the graph. I just don't know which graph you want. So it's waiting for me to pick one. And then once I have picked one, it will appear. And the way that we express that in code is very simple. So we start with validate, and then you can put multiple need statements, and each need statement relates to a particular input. So I've only included one here. It's waiting for this value of trust, this thing here, to have a value. And basically it just checks whether this has got some sort of sensible value. So the things that don't count as sensible values, I forget what they are off the top of my head, but it's what you'd expect. Null values don't count, NA values don't count, empty strings don't count. I think possibly false doesn't count, that kind of thing. Things that are clearly not, what the application is wanting. So whenever this is not valid, it will give this error message. And as I say, a single validate call can hold multiple of these expressions with multiple error messages. So you might have one that says please select a trust, and there might be another one that says, please select a date range, or whatever, or please upload data, or whatever that might be. So validate can be very useful, and I haven't included an example here, but it's very similar. Also, the REQ function, which I'm sure must stand for require, that's almost the same as a validate function. It works in almost exactly the same way. The only difference is it doesn't return anything to the user. So, because sometimes you don't always necessarily need a message. Sometimes it's just recalculating. And while it's recalculating, you don't want these weird error messages appearing. So if you just write require input $trust, then it will just say to Shiny, until that's got a sensible value, there's no point running this, so just don't bother. And it will just not bother until it's got a value and just say, oh, it's fine now, it works, and then it will show. So that's a simpler way of dealing with error messages if you don't need to return feedback to your user on the state of the application. Right. Something else you might want to do is uploading and downloading files. That's very simple. Certainly uploading files is very simple using the file input function. That will just give you a little button that your user can press, and it will just launch a standard file browser, and they can select whatever it is, and then that will be available to the application. There's a download handler function as well, which also will produce a button which can download files. That can be a bit more complicated to use because obviously you need to have some way of, you need to produce the file for downloading, and depending on what you're producing, that could be more or less simple. The thing I wanted to tell you basically with this is that it's possible to render R Markdown in a Shiny application, which can be very useful. I'm not going to go into the technical details of this because it sort of depends what you're doing and how you do it, and it can change the code slightly and it'll confuse people. But do have a read or drop me a Slack if you're interested. Basically, the thing to understand is there are two main ways of doing this. You can either have an R Markdown button where you press it and it says, all the outputs that currently exist on the screen, just draw them in the state that they're in and put them in a file. Because sometimes people want that. They're looking at 5 different graphs and they go, oh, that's useful. Press a button and they all go down. And there's a particular way of writing the code that's quite simple that will do that. Or the other thing you can do is you can do what's called a parameterized R Markdown report, which for those who are not familiar, that means an R Markdown report that will accept certain values. So for example, a value for date, and it will draw something different depending on what that parameter is. And Shiny can produce parameters that go in our Markdown reports. So that's a slightly different approach, and the code looks slightly different, and it does a slightly different job. Oh, you can certainly do both. So I say I'm not going to go into that because it gets a little bit. It's not complicated. It's just a bit different. That's all. It's a bit. Yeah. There's just a couple of different approaches, but it's worth knowing that it's possible, and it's worth knowing that those are the two sort of main approaches. Okay, I haven't got a huge amount of time left. I'm just going to show you this very quickly because I hate Plotly, and everybody uses Plotly because they want to have little hover instructions on their applications, and I don't use Plotly for religious reasons. And I think people think it's very complicated to have hover events in Shiny applications, and it's not really. So I'm just going to show you very quickly. So if I just go over to the map, so let's just select an NHS trust here, Northern Lincolnshire, and you can see here if I hover over the points, you can see that it updates down here. Oh, I can't. Underneath it says where the attendance is. You can see it will tell what that value is. So it's not quite as slick as Plotly perhaps, but you can do it yourself, which is nice, and it's not that and you've got the flexibility to approach the problem how you like. So just to very quickly show the code for that, basically all you're doing really is it's just this near points function. So all you do is you have to get the data that draws the graph, just fetch that however you do it. I'm not going to go into too much detail here, but you need to have that data here somewhere, and then just call near points on it, and this value of this is predefined. Let me just show you quickly where it's predefined in the UI section. Where is the UI section? Where are we? Just here. So you can see I've just added a single argument to here. So plot output one graph hover equals plot hover. So I'm just giving a hover event a name. Then you can see I can very easily pick them up in the code. Here, oh, that says click. That's obviously an old version of the code. Yeah, I changed it to hover from click, but same difference. It's this name anyway. And this will just return the values of the data frame that are near that click. And then all you need to do is just subset, find whatever the column is that you want from that data frame, and then just paste it to the screen. And it's as simple as that. So it's probably not that easy to follow in a webinar, but as I say, if you just have a quick look through the code, it should make a lot of sense. But the main point of telling you that was to tell you that it's quite easy, really. Interacting with the map, I'm slightly running out of time, so I'm not going to talk about that. You've seen me do it. So this is something else that I've written where you can, this little nice pop-up appears and it will tell you the attendances and breaches in that area. Again, it's not particularly complicated. Essentially, the meat of it is using this leaflet proxy function, but you can have a pick through the code of that offline, and certainly Slack me if you're interested. Right, just a couple more things to tell you before I close out. It's worth knowing that there are lots of packages for Shiny. Actually, I don't have time. There are loads and loads and loads, so have a look around. The one I wanted to flag up to you is Shiny Dashboard, which is basically just for when you get bored of all Shiny applications looking the same. But then, of course, all Shiny Dashboard applications look the same as well. So then you've got to find something else to make them look different to that. Shiny Dashboard applications look like this. This is something that I drew. They tend to all look like that. They have these nice big coloured buttons, which are quite nice. And you can put little smiley icons behind them. So it's quite sort of attractive and user-friendly, I would say. Right, very quickly then, so debugging. So this is debugging Shiny applications is very hard. And if you follow me on Twitter, you will occasionally see me screaming about this very thing. So I've got a couple of pieces of advice for you. So the first one is write simple code first. Don't write anything complicated first. Start simple, which I know is obvious, but you should see what people post on Stack Overflow. The second one is make sure any code that you work works outside of Shiny. And again, that sounds very obvious, but you'll be surprised the amount of people on Stack Overflow who are posting code in Shiny applications that does not work outside of the Shiny application. Using cat can be very useful. So if you write cat somewhere, particularly if you write cat of str, so cat brackets str brackets data frame, it will print the structure of the data frame to the console. So anything basically within a cat thing within a piece of server code will be printed to the console. So that's the way. The problem with Shiny applications is because they're running live, you can't poke around on the inside of them like you normally can when you're running interactively. So cat, you can put that anywhere you like and it will just print whatever's inside it. It will print to the console what's going on. So that can be very, very useful indeed. You can use the usual stuff, breakpoints and browser, all that kind of stuff. And the only other thing that's worth telling you is that there's a nice thing where if you run with option shiny.reactlog equals true. So put that in, run the application, have a click around, do the stuff that you're interested in, and then press Control and F3 on the browser. And then this nice interactive summary will come, and you can actually click through. So it shows each step. So it shows this input spawned, and then it updated this, and then this had another thing value, and it actually shows the way that values propagate through the application. And that's very, very, very useful. That has saved several of my applications. So if you get stuck, have a look at that. Right, okay, so I've really only got a couple of more minutes now. So I'm going to return to the question that we had about the single file thing. So let me just say a couple of things about that. As I say, yeah, that's the intro done. So if you're still learning about Shiny, don't be worried about this. Just go to sleep or have a cup of tea, or just don't worry about it. But for those of you interested, yeah, basically long code files are bad. So the problem with Shiny applications is the server file tends to get very long. So what I've done in the past is the only thing that goes in my server file is any render UI call. So anytime that I'm producing reactive user interfaces and any reactive expressions, that's all, everything. That's all the server file. Everything else gets hived off into its own code file, usually one per tab. So each tab will have a different code file. And all you need to do is you just need to call source local equals true at the top. And that's it. So a lot of my Shiny applications have got about 6 or 7 source instructions at the top. And that works pretty well. I was quite happy with that. That works pretty well. However, things are changing, and I want you to know about this change if you're sort of intermediate to expert Shiny user. So in Shiny 1.5, which is not released yet, but which is coming, it automatically sources the contents of the R folder. So there's absolutely no need to source files locally anymore. You just put them all in the R folder, just like when you're using an R package, and it's all done for you automatically. Hadley Wickham's book, which I mentioned at the beginning, assumes that you use single file. There's no mention of two files. They don't even say don't use them. There's no mention of it. It's just single file. So I feel like that's sort of on the horizon, and I want to be there to kind of be ready for it. The other thing I think that Hadley is emphasizing is separating business logic from Shiny functions. So what that means is the functions that go in your R folder probably won't have reactive inputs to them. They won't have reactive inputs called within the actual body of the code. They will accept reactive inputs as arguments, but the functions themselves should work outside of a reactive context. And that obviously means that they're easy to debug the problem and test. The problem with Shiny applications is they're very difficult to test, because the way you test a Shiny application is you launch it and then you just click around randomly. And there's no although you can automate that, it's a bit complicated, and testing is a bit shonky that way. So this is what I think Hadley is emphasizing. And also Golem is, and that's the next thing I'm going to talk about. Right. So, but the other thing to say about the two file thing is Golem, which is the other thing I'm learning, uses two files. So I don't know which way to look at the moment, to be honest. So Hadley's saying use one file, but Golem is saying use two files. So what is Golem? So Golem is an opinionated framework for building production grade Shiny applications. So basically what it does is it makes, if you want to build a Shiny application in Golem, it has to be a package. Like, that's how it works. It's a package by default. And they emphasize the use of modules. So the idea with Golem is everything's a module, and everything's a package, which is really good because it makes it very easy to deploy them and to test them, because they've got that modularity built in and they've got that package built in. So you should be able to deploy a Shiny application to CRAN out of the box. It should just work. I mean, obviously you've got to pass the CRAN checks, but it is a package. So Golem, I think, is going to be really, really, really important, and that's something that I'm looking to really build up to start using that regularly. So, but as I say, in terms of two code files, so that's two code files. Hadley also one code file. So everything's a bit up in the air at the moment, but I want you to all to know about that. And that's it. I have very naively put some stuff at the end just in case I didn't have more to talk about, but obviously I have, if anything, gone slightly over my time. But if you see anything on the screen that you think sounds interesting, then you can ask a question about it now, or you can cite me later.
Thank you very much, Chris. So yeah, we've got quite a few questions to run through now. One question was asking a little bit about the Golem package. So I think you've just covered that. I think it's pretty new, isn't it? And there's a lot to learn with Golem. So that's perhaps one for a future webinar, I think.
Yes, well, I would be really interested in it. I'd be more than happy to run a webinar on Golem. If it seems a bit, I don't know how many people are interested. I don't know how obscure that is, but I would be more than happy to do that because I really think it's important.
Brilliant. So the next question that we've got is, how would you rate Shiny in comparison to Tableau and I suppose other platforms like Power BI and Click in terms of efficiency and best to use? And I think we should preface this with Chris is rather opinionated about open source technologies and platforms, so I might jump in with my own response afterwards.
I mean, I just know that Gary sent that question just to why he's trying to get me fired. He's trying to get me on a rant on a Microsoft Teams call. The truthful answer is I don't really know. I think people often ask me questions like this. I gather Tableau is very well featured and easy to use. I think the thing about Tableau, I mean, I've never used it. It sounds really good, but I gather it's very expensive. So yeah. I think for me that would be in the cons column for Tableau is the expense of it. I think Power BI, I gather, is very easy to use, and I think it will do. I think the thing about Power BI is it will do a lot of stuff easily. So if you want to do reasonably basic dashboarding, Power BI is really good because it's easier. You don't have to write code. I think the thing, and this is a fairly naive conception of Power BI that I have, I think the problem with Power BI is it doesn't really let you go behind the scenes and really tinker with everything. So the thing about Shiny, obviously, because it's all R code, you can make inputs and outputs of arbitrary complexity. So you can, in theory, build an output that depends on 3 inputs that themselves depend on 2 other inputs that depend on the value of an output of an input. And that's not. I don't think you can do things like that in Power BI. I think it's just basically just based on pretty much the data structure that exists.
You can
From
create
my part, what I would say
controls
about
for Power
Shiny
BI.
is I write all my code in R. So to me, it's totally natural to use Shiny because I'm sitting in front of a load of R code. I don't have anything else. So for me, it's a non-question, because why on earth would I take loads and loads of R code and then there's no point translating it. So that's not very, to be honest, that's not a very good answer. I don't know very well, to be honest, but that's my summary of what I understand.
Yeah, I think my takeaways would be, Power BI, Click, Tableau, they are really geared for rapid business intelligence development, and they're great for when you've got tons of data you need to summarize and just build your dashboards with. Shiny it can do all of that, but you've got a full programming language behind it. So if you want to build, some kind of interactive SEIR model that's obviously all the rage at the moment, you could build that really easily in Shiny, and you might struggle to do some of that those kind of parameterized interactions in those other tools. Anyway, next question. So we've got a couple of questions here about kind of the server use, so running it on Shiny.io versus Amazon. Is it easy to upload our Shiny apps for online users, or is there some license required? What are the options for deploying Shiny apps server internal to organizations, RStudio? And another question is, where do you usually host your apps? Do you host it on Shiny.io or Shiny server? So I've tried to group as many of those questions all into one. So
yes, that's a good point. I haven't really touched on deployment actually, which is perhaps a weakness. I maybe should have put a few slides. So I'm glad someone asked that question. I've never used shinyapps.io. I imagine it's very easy to use because it's obviously the sort of RStudio out of the box solution. So I think if you're going to pay for it, and if you have data that you can put on someone else's server, then I imagine it's a very good choice. Me personally, I actually have two different Shiny servers. So I have one in the cloud, which we've been running for years. I think we started using it in 2013. So that's the open source version, so it's free. And I've never had any problems with it, so it's free. We just run a cheap cloud server that costs, I don't know, about £400 a year, and there's no security. The data's all open, so it runs fine, no problem at all. And I run another one which is behind the firewall, so we have another whole Shiny setup that's got patient data on it, and as a consequence, it needs to be hosted behind the firewall, although arguably it doesn't, and the NHS needs to wake up to the fact that cloud provision is just as secure as firewall provision, but let's not get into that. And B, it needs security behind the firewall even. So just because you work for my trust, it doesn't mean that you should have access to this data. So we actually have access control behind the firewall. Now that's a Shiny Pro license. Shiny Pro licenses cost $10,000 a year. And they give you 20 simultaneous users. So I gather you can pay for more simultaneous users. You should know RStudio is really trying to phase Shiny Pro out in favor of Connect. And I'm trying to stop them from doing that. It's kind of annoying me that they're doing that, really, because I think Shiny Pro is a really nice, cheap and cheerful way to get into, and that's certainly how my trust got into it. It was a sort of, $10,000 a year. It wasn't very much. And having used it for a while, I think you can then start to build maybe to use something a bit more expensive like Connect. It just runs on an Ubuntu virtual machine. So we have, obviously it's a Windows environment behind the firewall, of course it is because it's the NHS, but we have an Ubuntu virtual machine. It was a bit fiddly setting it up, so I had to set up Kerberos on it, and I had to set up accessing LDAP with Active Directory, which were both a bit annoying. I've got blog posts on them if anyone's interested, and certainly you can drop me a line if you want to talk more about that.
Yeah, so that's a question that's just coming about the adding in authentication to the free version of Shiny Server, and perhaps that blog post might be a good start. I think in the interest of trying to get through a couple of the rest of the questions, that's something that you'll probably be best to just ask Chris on somewhere on Slack. I'm sure he'd be more than happy to pick that up later. So the next question, I'm just scrolling back up a touch in my list here. Could you please provide a quick example about the dynamic UI that's featured in Shiny?
Dynamic UI.
Yes.
Is that? I think I know what they're talking about. I think they're talking about this bit that I was talking about here. So this is dynamic UI. So this in the application that I made for this purpose. This is a list of trusts, but some of these trusts are really weird. They sort of like Badger Limited, for example. What on earth is that? And they sort of ping in and out of existence. So you can see here, it didn't exist before 2017. So you can see if I wind the clock back, and let's just go to the where should we go? End of 2016. So that will produce a different set of trusts, and we can now see that it's disappeared. So as I say, it's useful when you've got a lot of things, but you don't know which particular set of things that they want to look at until you know what in particular they're interested in.
So as a follow-on to that, say if you had a drop-down that had a set of options like A, B, and C, and option A will bring through another list of options 1, 2, and 3. Is that where you would use this kind of dynamic UI?
Yeah, well, I've actually, funnily enough, I've got a better example that I can show. I can't really show the code because it's too long and complicated, but I've got a good example of something. This is a real application that I use in my trust. Hopefully it's going to load in time. And
that's a beautiful segue into the next question then about any examples of where you've used this in an NHS setting. So
yeah, so here it
is.
So this is our patient experience data. So this is a live application that you can use. It's on the internet. Anyone can look at it. And so you can see here, so this is a good example. So we actually have 3 different divisions within our trust with different things in them. So there's a lot of teams. So if you click, say, this one, it will narrow down this box. So this box now has only got the directorates that are in that division. And then if you click that, it will narrow it down even further. So let's click there. Then a teams box will show up, and then it's only got 5 teams in it. But if you remove those, you can if you want to. There's a show all teams button which comes with a warning because it says there are a lot of teams. So if you just do it naively, it looks like this. So clearly nobody wants to use this because it's, as I say, I think there must be about 200 teams in there. So that, and that's why. So I built this a long time ago, and it has that exact click through for that exact purpose of not drowning people in data.
Excellent. So this is one example of where you're using Shiny in production. Can you just give a little brief explanation of this, and maybe a little overview of any other areas that you'd like to highlight that you're using Shiny for?
Well, this is the main thing that I use Shiny in production for that I can show you. If anyone wants to drop me, I think we have got a fake version of because the one behind the firewall has got patient data on. We have got a simulated version of it somewhere. I don't have that to hand though, but if somebody wants to Slack me, I can certainly show you. I think that's it really. I mean, I do use Shiny for all sorts of weird and wonderful things. So if people send me like a big data set, sometimes I'll just make sort of, an application that allows them to click through it or that kind of. So I build lots of small Shiny applications. But in terms of sort of production, this is basically, it's patient experience, and it's the other thing that I mentioned that I can't show you because it's behind the firewall. So yeah, this is Shiny dashboard. I mean, there's quite a lot of different things on it. So there's like there's a bit with all the graphs, and there's a bit with tables. The tables are quite nice because they're all interactive. So this shows the different things that people have been talking about, but this is all interactive. So you click on here, it will show you the individual categories within there. And if you click within the individual categories, it will show you examples of the text over there. So that, I hope, is a pretty good example of how adding interactive elements to Shiny application, which, as I say, is not particularly difficult, can make it quite user-friendly.
Great, thank you. And I think that's about all of the questions. That's, yep, all of them so far. So I think that is closing out the session beautifully, unless you've got anything else you want to say, Chris?
No, I don't think so. No, I'm all done.
Great. Yeah, that's been a real whistle-stop tour of Shiny. It's a very full-featured product, and hopefully it's been useful for you all.